Welcome back to geometry. This video is going to cover 18.2 in the textbook, 18.2, surface area of prisms and cylinders. Here we have the warm-up. We just want to find the area of this pentagon. Assume it's a composite shape of a rectangle and a triangle. So let's see here. We've got a triangle on top, and then we've got a rectangle on the bottom. So let's do the triangle first. Here's our base. The base will be the same as down here at the bottom of the rectangle. Our area of a triangle is 1/2 times the base 7 times the height 4. 4 is from right here. And let's find that first. Half of 4 is 2. 2 times 7 is 14. So the triangle has 14 square meters. Our rectangle is as easy as base times height. 5 times 7 is 35. If we add those together, we get 49 meters square. All right. So here we go again. This is 18.2. We are going to develop a surface area formula for a right prism. So, surface area is the total area of all faces or sides and curved surfaces of a 3D figure. The lateral area of a prism is the sum of the area of the lateral faces. So just exclude the top and the bottom, the bases. Just look at the sides of the prism. That is the lateral area. A net is a diagram of a 3D figure arranged in such a way that the diagram can be folded to form the 3D figure. So we'll get a better look at that here on the next slide. Here's a net. On the left side, we have a rectangular prism, length and width and height. And then here, we sort of broke it all apart. If I color in this, the length times width, that would be maybe length times width. And then connected to that, the front of the box would be height times length. So here's height times length. And then we would have that other long side. And then this side, the top, and the other side would sort of unfold out this way. But if we look at it, here is our length width on the base. Here's length width on the base. Here's length width on the top of the box. That would be this length width on the top of the box. And let's see here. So the back and the front side, this would be the height times the length. So here's height times length. That's kind of this front of the box. And then the exact same side would be at the back, height times length. That's right here. And then this side here on the right is height times width. We switch to black ink. Height times width. And then over here on this side, we would also have height times width. So there it is, all unfolded. Example 1, part A, use the net of the prism to write a formula for the surface area. So let's do that again. Here's our bottom. That's length times width. And we've got, that's the bottom of the box, and here's the top of the box. So we're going to have length times width, and then we're going to have 2 of them. And actually, I'm just going to write it down here. 2 times length times width. And now I've got the front of the box. That would be length times height. And that would also be true at the back of the box, length times height. So we've got 2 lengths times heights. And then on the left and right side of the box, we have this side. That would be height times width. Same on this side, height times width. So we also have 2 of those. So here's our formula to find the surface area of that shape, or the area of this net. Now we're just going to plug some things in. L is equal to 8. So I'm going to write it over here. L is equal to 8. Width, W, is equal to 9. Width is 9. And the height, H, is 2. H equals 2. So our first thing here I've got in black ink, that's going to be 2 times L times W, 8 times 9. And then in the middle, we're going to have 2 times length times height. That's going to be 8 times 2. And then finally, we're going to have 2 times height times width. 2 times 9. 2 times 9. And let's do a little multiplying and adding. 8 times 9 is 72. And if we double that, we get 144. plus 2 times 8 is 16. If we double that, we get 32. 2 times 9 is 18, and we double that and get 36. And if we add those three numbers up, we should get 212. Our units are centimeters, and since it's area, those are squared centimeters. So if we wanted to paint the outside of this box, we would have 212 centimeters squared. We would need that much paint to paint the outside. All right, example 2. I like to think of this as a Pringles can. Here's the top of our Pringles can, here's the bottom of it, and then we've got the side sort of wrapped around those two circles. So if we break this apart and flatten it out into a net, we're going to have a circle on the top and the bottom and this rectangle. So for part A, we're going to label the radius R. I'll put it right there. It would also be here, I'd call this the top of the Pringles can. Down here would be the bottom of the Pringles can. H would be the height of the cylinder. So I'm going to hit that here in red. That's our H. That's our H. So what we've got here are 2 circles plus 1 rectangle. The circles aren't bad at all. So we have our 2, and then the area of a circle is pi r squared. So we're going to have 2 of those. And then now for the rectangle, this might be the tricky part. Call this the base and this the height. Well, I'm going to put an empty set of parentheses for the base. The height is just h. Now think about this. This top edge that I'm hitting in red ink, when we wrap it around the circle, it should go all the way around the circle like this. So what is this part of the circle I'm tracing in blue? That's the circumference of the circle. And the circumference of a circle is 2 times pi times r. All right, so that's the base of our rectangle times the height. So use the net of the cylinder to find a formula for the surface area. Here we have it. And now we're going to plug in some numbers for part B. It says we have a diameter of 10 inches. So if diameter is 10, radius is 5. And the height is also 5 inches. So I'm going to turn the r's and the h's into 5s. And again, this is for part B, but I'm going to do the work up here. So we're going to have 2 times pi times r is 5, and we're going to square it, plus 2 times pi. This r is a 5, times this h is a 5. Now, if you're reaching for your calculator, don't bother. We don't need it. 5 squared here is 25. 25 times 2 is 50. And we're going to multiply by pi. So we have 50 pi's for the first term. And then here, we've got 5 times 5 is 25. Times 2, again, is 50. So we have another 50 pi's. What's 50 pi plus 50 pi? That's 100 pi. And I guess let me write it down here. 100 pi is our exact answer. And then if we want to turn that into a decimal, I'm going to use approximate. And the decimal of pi is 3.14159. If I want to multiply that by 10, I'm just going to grab the decimal and move it 2 spots to the right, once for each 0 in our original problem. So it looks like the surface area of this cylinder is 314.159. Our units are inches, and we're going to square. Find the surface area of this composite figure. We've got a small house. So I'm going to move this up here so I have a little more room, and I'm going to try to color code this as best I can. Let's start with the front of the house. I'm going to sort of block it off in a red rectangle. So that's the front of the house, and around here to the back, we will have a mirror image. So we're going to have 2 of the front of the house rectangles. And our base is 16, and our height is 6. So that'll be 2 times 16 times 6. And again, that takes care of the front and the back of the house. Now I'm going to come over here to the left side. We've got this blue that I'm marking off here as a rectangle. And again, if I call this the left side of the house, we're going to have a mirror image on the right side of the house around back that we cannot see. But we're going to have 2 of these blue rectangles. And the rectangle is 6 times 12. All right, I'm going to go to black ink now, and up here we have a triangle up on top. Now I did sort of slide it, we can barely see it. This center bar here is marked at 4 feet, that would be our height, and the base of this triangle is also going to be the same as we see down here at the bottom of the rectangle. So we're going to have plus 2. Now in here we're going to put the area of a triangle. 1/2 times the base is 12 times the height is 4. Okay, and now it looks like we've got to do the roof. I'm going to go back to red ink. I'm running out of my different colors. Up here is the roof. I'm going to sort of block it off this way. It is another rectangle. So the base of the rectangle is going to be 16, and the height of the rectangle here on this side is the 7.2. So we're going to have 2 more rectangles, and those are going to be base 16 times height 7.2. All right, now that's all the stuff we can see here above. We do have to put the floor in there, the bottom of the house. So we do need one last rectangle. Put another plus sign here, and that's going to be 16 times 12. 16 times 12. Okay, and this first term, 16 times 6 is 96, times 2 is 192. And then we've got 6 times 12, that's 72, and we double that, that's 144. On this one, the 2.5 will multiply to a 1, and then we have 4 times 12. 4 times 12 is 48. And then, what do we got next? 16 times 7.2 times 2. That'll be 280.4, I believe. And then finally here, we've got 12 times 16, and that's a 192. And let me just check my work here on my paper. Got that, that. Yep, and if we add those all up, the surface area of our tiny home there is about 806.4 feet squared. All right, not too bad. A lot in there, a lot of little work to get the final answer, but it all worked out nice. What's next? Aha, apply surface area formula. I gotta fix this. Surface, there we go. Surface area can be used to answer many real-world questions. One use of surface area is population density problems. Population density is the number of organisms in a particular type per square unit of area. Think population density of New York City. Every square mile of New York City is going to have a lot of people stuffed in it because it's a very big city. If you look at the population density of Alaska, last I knew it was about 1 person per square mile. Alaska's huge and there's not a lot of people there. So I'm going to get this out of the way. We've got a treasure chest in our aquarium. Whoop. It is covered with algae. If the algae covered the entire chest, the population is about 30 million algae cells. What is the population density of the algae? So let me move this up here. I'm going to draw a little bit better picture. So this edge is 3, this edge is 5. We come across the front of the chest. That's 6. And there we go. So first, we got to figure out the surface area of the chest. SA equals. I always like to start here in the front. So this front rectangle I'm hitting here in red, that's going to be 5 by 6, and we have 2 of those. And then let's do top and bottom. This top here I'm hitting in red is 3 by 6, and we have 2 of those, 2 of 3 by 6. And then the last thing are the sides. So this side over here would be 3 by 5. This side over here is also 3 by 5. So we have 2 3 by 5 sides. So this will be 30. 30 times 2 is 60. 18. 18 times 2 is 36. 3 and 5 is 15, and we double that, and we get 30. And if we add all those up, our surface area is 126 centimeters squared. All right, now let's figure out the population density. Pop density. We've got 30 million algae cells, and they need to be distributed across 126 centimeters squared. And let me put my units up here. We'll just call it cells, algae cells. We have 30 million cells spread over 126 squared centimeters. So when we divide that out, let's round it to the nearest 1,000 because we've got a big number here. Approximately 238,000. And our units are numerator units per denominator units. So that will be cells per centimeter squared. Every square centimeter is going to have about 238,000 algae cells. Whew. All right. Now we get into the huddle. The lesson was kind of short, but some of these huddle problems are going to get a little juicy. So hang in there with me. The first one here, it says, suppose the treasure chest had dimensions of 12, 10, and 6. So now I'm sort of going to model this on the last one we did with the treasure chest. The longest side was across the front, so let's make that the 12. And then the second one was the up-down, so this side will be 10. And then the depth, or how far back it goes, that'll be the smallest number, 6. So we sort of keep it to what we just saw in that last example. Oops, wrong way. So surface area is the front here. This is going to be 12 by 10, and we've got 2 of them, 2 of 12 by 10. And then let's do top and bottom. The top here would be 12 by 6. And we've got 2 of those, a top and a bottom, 12 times 6. And then we've got the left and right sides. This side here would be 6 by 10. And we've got 2, we've got 2 of those, 2 6 by 10s. So this is going to turn into 144 plus 240 plus 120, maybe not in the same order that I did them up there. And we should get about 504 surface area, 504 centimeters squared. Now let's do the population density. It's the same 30 million cells. So we're going to do 30 million cells divided by 504 squared centimeters. And that turns out to be approximately 59,524 cells per centimeter squared. All right, that wasn't too bad. Up next, find the surface area of the following polyhedra. So let's look at this one here. The front face is 2 by 6, and then the back face would be the exact same 2 by 6. So we have 2 by 6s. And then let's do the top here. That would be 6 by 9, and the bottom would also be 6 by 9. So we have 2, we have 2 6 by 9s. That's supposed to be a multiply. 6 times 9. And then let's see the left and right side. This side here would be 2 by 9, and this side here would be 2 by 9. So we have 2 by 9s. So what's this going to multiply to 12? 12 times 2 is 24, plus 6 times 9 is 54. 54 times 2 is 108. And then 2 times 9 here is 18. 18 times 2 is 36. And if we add those all up, we get our surface area is 168 inches squared. Nice. Now in letter B, I'm going to sort of redraw the net we saw in the previous example. We're going to have a rectangle. Oop, that's a pretty terrible rectangle. I can do better. There it is. And then at the top, we're going to have a circle, and at the bottom, we're going to have a circle. So we need 2 circles and a rectangle. 2 circle plus rectangle. Well, we've got 2, and the area of a circle is pi r squared. pi r squared plus the height of the rectangle is easy. That's going to be 16. But just like we saw in the example with the Pringles can shape, the base is going to be the circumference of the circle. So that's going to be in there a 2 pi r. So 2 times pi, our radius is 12. If we square that, we're going to get 144. And then we're going to have plus, this 16 times 2 pi is 32 pi, and we're going to multiply by the radius 12. So we should get here in the first one, 2 times 144 is 288 pi, and then the 12 and the 32 multiply to 384 pi. Let me erase over here so I got a little more room. If we add the constants in front, the 288 and the 384, we're going to get 672 pi. And if we use our pi key, we can get a decimal, round it to about 2,111.15 centimeters squared. What's next? Letter C. Oh, this one's not bad. On this side, we have a triangle. And on this side, we have a triangle. So we're going to have two triangles. And actually, let's just dive right in and do it. So we're going to have 2. And the triangle here, it's a right triangle. So we're going to do 1/2, call the base 4, and the height 3. All right. Now, this side here in the back, it's got a height of 3 and a length of 11. Again, here's the height of 3, and this edge is 11, just like this edge. So we're going to have a plus 3 times 11. So now we just got to find this side right here. It's another rectangle. We're going to do base times height. This is an 11, but what we need is this side I'm hitting in blue ink. So we could do a little Pythagorean theorem. 3 squared plus 4 squared equals c squared. That would be our hypotenuse. So we've got 9 plus 16 is c squared. 9 and 16 add up to 25 is c squared. Take the root, c equals 5. So this will be 5 times 11. So here, 2 times 1/2, that's 1, so that's gone. 4 times 3 is 12. 12 plus 3 times 11 is 33. And then we've got 5 times 11, that's 55. Oop, and I think I forgot something. The bottom of the box. I was so busy scribbling over stuff, I kind of forgot. This is 4, and this is 11, so that's going to sort of be the base of this shape. So we need to add a 4 times 11. 4 times 11 is 44. There we go. I know I needed 4 numbers down here. So 12 plus 44 plus 33 plus 55. Our surface area is about 144. Our units here are feet, and its area, so it will be square feet. All right. The last one here looks a little intimidating, but it's actually not too bad. So let's just concentrate on the rectangular prism. So we're going to have 2 rectangles for the front and back. We're going to have 2 rectangles for the left side and the right side. And we're going to have 2 rectangles for the top and the bottom. And now we've got a cylinder sitting on top. So if we look, I'm going to use red ink. The top of the cylinder is a circle. And the bottom of a cylinder is the same circle, and that bottom of the cylinder takes away some of the surface area from the top of the box. So we're going to add a circle for the top of our cylinder, but then we're going to subtract the exact same circle for the bottom of the cylinder. So that's sort of going to wash out. And then we're going to need the lateral edge of that, let's just call it a Pringles can again. So it's going to be base times height. Once again here, the height is going to be 5. So we're going to have 5, and then we're going to multiply that by the circumference of that circle. So that's going to be 2 pi r. Okay, let's start actually putting some numbers in here. Let me erase Well, I guess I'll just leave it up there. I like to do the front and back first. So this is going to be 9 by 7, and we're going to have 2 of them. 2 9 by 7 boxes. And then we're going to have the sides here. That's 3 by 7. So we're going to have 2 3 by 7 rectangles. And then we need the top and the bottom. So here's the bottom. That's 9 by 3. The top will also be 9 by 3 plus 2 9 by 3. Again, we've figured out here the top circle is a positive circle. The minus, we would subtract it from the bottom, so those circles are going to cancel each other out. And now we have our last piece is the side of that Pringles can. That's going to be a 5 times 2 times pi times r. The radius is 1 meter. 2 times pi times 1. I'm not even going to write it in there. So let's see here. 9 times 7 is 63. And if we double that, we get, what, 126. Plus 3 times 7 is 21. And if we double 21, we get 42. 9 times 3 is 27. And if we double that, we get 54. Plus 54. And then we're going to have plus 2 times 5 is 10. 10 pi. So 54 plus 42 plus 126 plus 10 pi. We'll just do it in our calculator and round off our pi. Surface area is approximately 253.42 meter squared. Nice. What's next? Raul is wrapping a gift box wrapping a gift that is a box shaped like a rectangular prism. The box is 14 inches long, 8 inches wide, 3 inches tall. How much wrapping paper does he need to cover the box? All right, as always, I'm going to do my front and back first. That's going to be 8 by 3 and another 8 by 3. So we've got 2 8 by 3, and let's multiply that right now. 8 times 3 is 24. And then we're going to have the left side and the right side. Here, the right side is 3 by 14. The left side will also be 3 by 14. So we have 2 3 by 13s. That's times 42. And then we're going to have the top and the bottom. So the bottom is 8 by 14, and the top is also 8 by 14. So we've got 2 of the 8 by 14s. 8 times 14, I think, is 112. So 2 24s are 48. 2 42s are 84. 2 112s are 224. If we add that all up, our surface area is about 356 inches squared. I hope Raul has enough wrapping paper. All right, I think we just got 2 more to go. The first one's not bad. It's just another rectangular prism. It's got 6 sides, and they're all paired up. So let's do front and back. Here's 9 by 20. We've got 2 9 by 20s. Plus the right side here is 9 by 20. So we're going to have 2 more 9 by 20s. Yeah, I just noticed this side is 9 and this side is 9. So we do have sort of a repeat there. And then our top and bottom, this top here would be a 9 by 9. The bottom would also be a 9 by 9. So we have 2 9 times 9s. And what you should get here, again, you should have already solved this yourself. We should have got about 882 units are centimeters, and they will be squared. Okay. Now, in the last one, they kind of give us a little bit of a gift. Because it's a regular pentagon on the side. And then we have, and I'm number these as we go, 1, 2, 3, 4, 5 rectangles. And the nice thing here is they give us the area of this pentagon on the end. It says this side is 43 feet squared. That means the back side here will also be 43 feet squared. So we've got 2 of those 43 feet squared. Now, we do have 5. You know, this pentagon has 5 sides. And we're going to have 5 sides, and each side is a rectangle of 5 by 11. So 5 by 11. 2 times 43 is 86. And then 5 times 11 is 55. So we're going to have 5 times 55. So that's 86 plus 275. And if we add that up, our surface area of this shape is 361 feet squared. Dang, that was quite a lesson. Last problem. Video is over. I hope it was helpful.